Right, okay, this is lesson 5, part 2, and we'll call it powers and roots. Yeah. Now this can either be in algebra or in numbers. You get different kinds of questions here, and there are about 7 different rules to try and remember for all of this one. So powers and roots, powers and roots. Okay, so if we have 2 to the 3 times 2 to the 2. Right, first of all, we'll do this. 2 to the 3 is 2 cubed, and that equals 2 times 2 times 2, and 2 squared is 2 times 2. And that's all times together. 2 times 2 is 4, times that is 8. 2 2s are 4, so 4 8s are 32. So that's our actual answer there. Now, if we look at this line here, we've got 2, 2, 2, 2, 2. We've got 5 of them. So 5 of them will be 2 to the 5. Now, so 2 to the 3 times 2 to the 2 is 2 to the 5. Now, how can we do that without all of this stuff? Because we might not have numbers, we might have algebra. What we do is we add the power numbers. We add the indices, yeah? So when multiplying, add the indices. Add the indices. So, for example, all we do is just add them. Yeah. So if we've got x to the 4 times x to the 3, that will be x to the 7. Just add the two numbers together. Now, if we have a minus number, x to the 4 times x to the minus 2. Yeah, we're still adding them together. So 4 add minus 2, 4 add minus 2 is the same as 4 take away 2, which equals 2. You're adding them together. That's it. That's all we do. So if we have a squared b 3 times a 4 b 6, you do the numbers, you do the letters individually. So you do the A's first, yeah? A, 2 and 4 is 6, and B, 3 and 6 is 9. Yep. Can we make that even more complicated? 2A squared B 5 times 3A 2 B minus 2. Right, that's how complicated it's going to get. So do the numbers first. 2 times 3 is 6. Now do the A's. We've got 2 and 2. 2 add 2 make A to the 4. And the B's, we've got 5 and minus 2 is 3. Yeah. So that's adding when you multiply. So if you divide, and we've got x 7 divided by x 4, when we divide, you subtract the indices. So 7 take away 4 is 3, so that will be x to the 3. X to the 10 divided by x to the 2 will be x to the 10 take away 2 is 8. X to the 10 divided by x to the minus 4. Now, be careful. We're going to subtract. So you've got 10 minus 4. And the two minuses make a plus. So that will actually come out to be x to the 14. So be careful when you've got the minus things going on. Okay, so that's when you divide, you subtract the indices. So we've got multiply and divide. Now, one root raised by another. This means x to the 3 raised by something like that. Yeah, one root raised by another. Multiply the indices. So that will be equal to x to the 3 fours are 12. Yeah, x to the 3 raised by minus 2. Multiply the indices. 3 times minus 2 is minus 6. Yeah, happy with that? Good. Multiplying, just raising by the other. Well, we've got a number in there. Say 4x cubed 5. Yeah? So that is the 5th to the power of 5 for both of these numbers. So that will come out as 4 to the 5 and x to the, remember, multiply x to the 15. Now 4 to the 5, I'll save time and do that on the calculator. 4 to the power of 5 is 1024. So you'd have 1024 x to the 15. Yeah. Powers raised by another. Okay, so there's a couple of odd ones here. We've got negative and we've got positive, but we can also have, let's do a division. X to the 4 divided by x to the 3. So we subtract, so that will equal x to the 1. X to the 1, we normally just write x, don't we? We don't put x to the 1, but you're going to need this when you do subtract sometimes. Now, if I have 2 to the 4 divided by 2 to the 3, that will be, because I'm using the same powers, so I get to the 1. Yeah, 2 to the 4, 2 times 2 is 4, times 2 is 8, times 2 is 16, divided by 2 times 2 is 4, times 2 is 8, 16 divided by 8 equals 2. Yeah, see, this number here, whoop, 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 this number here, I'll bring it round, this number 2 is equal to that number, and this letter x is equal to that letter. So we've got the rule here that anything to the power of 1 is itself. We never really write the 1. X to the 1 equals x, 99 to the 1 equals 99, a to the 1 equals a, and so on and so forth. So they just equal itself. So when you're taking away the indices, if there is a 1, make sure you take note of it. Now the reason why you need to be careful about that 1 is if, let's go back to blue, I don't like the red, is if you've got x to the 3 divided by x. Now we're taking away, so you'd think at first glance that would be 3 take away nothing, which would equal 3, but it's not, because when, remember, anything to the power of 1 is itself, so you must put a 1 in there, or remember that there is a 1 in there, so that when you get your answer it's 3 minus 1, so you get your answer of 2. So be careful on that one. Well, let's put a number in there, shall we? Yeah, instead of the x's. 2 to the 3 divided by 2. 2 to the 3, 2 times 2 is 4, times 2 is 8, so that would be 8 divided by 2, which equals 4. 4 is the same as 2 squared. Yeah, x squared, 2 squared. 2, 2, 2 squared, x, x, x squared. So we've got to have the 1 in there. Got to have the 1 in there. So anything to the power of 1 is itself. And what about x to the 5 divided by x to the 5? Remember, we take away. 5 take away 5 is nothing. So you must put the nothing there. Yeah. 2 to the 5. 2 to the 5. 2 to the 5 is, can't remember, 1024 I think. 2 to the power of 5. Oh no, it's only 32. So that equals 32 divided by 32, which equals 1. We're dividing it by itself. So x to the 5 divided by itself is going to be 1. So x to the 0 equals 1. So another rule there is anything to the power of 0 is 1. Yeah, anything to the power of 1 is itself. Anything to the power of 0 is 1. Right, so now to do some fractions where it gets, we'll wind it up a little bit and do some fractions. So should we do some numbers? Some fractions. Fractional powers? Yeah, okay. Let's do 25 to the half. Okay, it's a positive half. Right. So 25 to the half. This determines the root in the next line, and this determines the indices also in the next line. So what we do is we write the 25 and we put a root sign out. It's a square root, so that goes down there. We don't need to write the 2, it's a square root. And the 1 would mean that all would be to the power of 1. Now, anything to the power of 1 is itself, so we may as well just do the square root of 25, which equals 5. Let's try and do some different numbers there, just to demonstrate what we're up to. So we'll have a go at 27 to the power of 2/3. Right, so this determines the root. This determines the indices or the power. Yeah. So we write the number 27, we put a root round it, and then we go 3. And this tells us the indices is everything is squared. So we'll do that, and it's all squared. So that number goes there. Now the cube root of 27 is 3. 3 3s. 3 times 3 is 9 times 3 is 27. So that lot comes up as 3. And then don't forget the squared there. 3 squared equals 9. So there's a fractional power. Right. How about a negative power? How about 4 to the minus 2? Yeah, a whole number, negative power. What we do here is we use something called the reciprocal. Now, the reciprocal of examples here. The reciprocal of 2/3 is 3/2. So you turn it upside down. The reciprocal of 3/4 is 4/3. The reciprocal of 10 is 1/10. Now the reason why it's 1/10 is because 10 on its own could be seen as 10/1. Yeah, if we were multiplying fractions. So we just turn it upside down. If it's a whole number, we write 1 over the whole number. So there's our whole number, so we write 1 over. So that comes as 1/4. So what do we do with this minus squared? So the squared comes down here and we lose the negative. So 4 squared is 16, so that equals 1 over 16. So there's a negative. Put 1 over and then square it out. Reciprocal, lose the negative. Another example of that is 3 to the 4, but we'll do the minus 4, 3 to the minus 4, so reciprocal 1 over 3 to the 4, and 3 to the 4 is 3 to the power of 4, 81, so that becomes 1 over 81. Okay, so we've done fractions, we've done negatives, now we'll combine the two to have negative fractions, which is probably about as complicated as you can get with this kind of thing. So let's do a negative fraction. What shall we do? Let's have a really tricky number there. That's not really tricky, is it? Minus 2/3. Okay, so it's the same as the other one before, but we're minus 2/3. So first job is to get rid of the minus number. So we put 1 over 27 and 2/3. Now it's going to get a bit messy underneath, but bear with us. Yeah, 1, or is it? Yeah, 1 over 2/3. So this is going to be 1 over the square root of the cube root of 27 and squared. Yeah, the cube goes down there, the denominator goes down to the cube root, and the top number 2 numerator goes to there. So the cube root of that is 3. 3 squared is 9, so your answer is 1 over 9. Yeah, there was a bit in the middle there where 3 squared. Yeah, so I went that way and then I went that way. 1 over 9. So you can do minus negative fractionals. Ooh, good. Right, what happens if we've got a fraction inside? What happens if we've got 2/3 squared? Now, remember that the square, when it's raised by another power, we multiply it in, but we haven't got any in there, have we? We've got a sort of, we could call that a 1 and a 1. Yeah, so we get 1 times 2. So that would be 2 squared. So we just put the 2 in with the number over 3 squared. That's 4 over 9. 4 over 9. So now this one, let's turn it upside down. Let's do 2, 3, or turn it inside out, whatever you want to do. Now we're going to have minus 2. Now remember, when we get rid of the minus, we do the reciprocal. So in this case, we turn it upside down and we end up with a positive. Now we apply the square to each bit individually and we get 9 over 4. So we could simplify that, don't know whether we would need to, as to be 2 1/4. Okay, this is a tricky old thing. So you can, you could go bonkers because I have combinations of all sorts of stuff here. Yeah, x to the 6 raised to the power of a half. So 6 times a half, or a half times 6, is 3. So that would just be x to the 3. Now this one, last one. 27 over 2/16 to the power of minus 1/3. First of all, get rid of the minus by going 216 over 27 to the third. Now, we apply the third to each thing because it's going to be 1 times the third. So we would get 216 to the third divided by 27 to the third. Now, that's the root. No, there's only 1 there, so we can just go the cube root of 216 divided by the cube root of 27. Now I know the cube root of 27 is 3. Not sure about this. So let's have a look. Cube root of 216. Probably 6, I think. Yes, it is 6. So that will be 6 divided by 3, which equals 2. Okay, so that's using powers and roots. So that's the second part of what we did in lesson 5.